Hello to dear friends from the Internet Librarian Connect 2023. This is Meng Q. I'm a web design librarian at the King Library from Miami University in Oxford, Ohio. And the voice you are listening is generated by a model from my own voice. I'm accompanied by my talented developer team, Aya Quirala, our lead chatbot developer, and Nut Steve Du, our lead software engineer. We're excited to showcase to you a groundbreaking piece of technology that we believe will revolutionize online patrons' user experience in academic libraries and pave the way toward the era of artificial intelligence facilitated library reference services. Before we delve into the topic of introducing the smart chatbot, let's briefly review the technological evolution in recent years. We've seen the emergence of artificial intelligence, the growth of machine learning, and the progression of natural language processing. We've tested some substantial large language models, such as OpenAI ChatGPT, Google's Bard, Microsoft's Bing Search, GitHub's Copilot, and Cohere, to name a few, which are now available to almost everyone. This technological progress has collectively incited the development of intelligent conversational agents, also widely known as auto-answering chatbots. Significant progress in this sphere has opened doors for the use of chatbots in a variety of areas such as customer services, information retrieval, and user support. I just name a few. Within this AI blooming era, you might ask, are there similar products available in higher education territory? The answer is yes. A blog page on global admissions listed some examples of universities using LLM for virtual assistants. Georgia State University uses a chatbot named Pounce to assist with admissions, financial aid, class registration, campus resources, and more. University of California, Berkeley has an AI-powered chatbot called Berkeley Chatbot, available to provide to help with inquiries from both students and prospective students. Deakin University has a chatbot named Genie, who is available to help prospective students with any information they need. When moving toward the area of online library reference services, in the last 5 years, our online library reference services have been served through a chat box managed by librarians using SpringShare LibChat, catering to an average of 3,000 chats annually. The previous data analysis work with subject extraction and text classification in these past questions allowed us to differentiate between quick fact questions and in-depth research inquiries, leading to the creation of a statistical model. This model shows that approximately 20% of all questions are quick fact questions dealing with facility and equipment reservations, policy clarifications, rapid information retrieval, citation assistance, navigation of subject guides, and other similar questions. We believed that these could be effectively handled by an auto-response chatbot if properly integrated into the existing Integrated Library Systems (ILS). Hence, the team of developers at King Library, Miami University began to utilize existing AI services to create a unique smart chatbot interface. Initial tests were conducted using Google Dialogflow ESS, supported by a backend framework through Node.js. These early experiments confirmed that Dialogflow could partially accomplish our objectives, like automating basic tasks. However, it required significant human programming for text classification. Dialogflow lacked the capacity to properly identify which virtual agent should be used when a question arrived, and the whole working efficiency was disappointingly low. With the emergence of the GPT-3 model and its subsequent upgrade, GPT-4, a new opportunity for improvement came into view. GPT-4 demonstrated an enhanced understanding of human languages and the ability to generate human-like text. With its introduction in spring 2023, the Smart Chatbots development team saw the potential for incorporating GPT-4 into user input and question classification. As a result, the accuracy of assigning the appropriate virtual agent increased compared to the early version of the Smart Chatbot. Incorporating the power of GPT-4 and related innovative technology, This intelligent chatbot embodies a pioneering solution tailored precisely to the distinctive demands of academic libraries. Its application aimed to demonstrate the potential of sophisticated AI capabilities in understanding user inquiries as well as maintaining continuous conversations. Proper programming structure in Node.js allowed for user inputs to be accurately classified and directed to the correct virtual agent. In each turn of a dialogue, the browser-side caching model saves the context. This enables the user to retain the conversation as if talking to a memorable human. Moreover, a comprehensive error handling mechanism was put in place. With its power, this system is transforming the way online reference services are rendered and elevating the overall user experience. We foresee an increase in chat numbers with the introduction of the Smart Chatbot option, with the goal of leveraging cutting-edge technological advancements to enhance user engagement and satisfaction through efficient task handling and personalized interactions. We named this intelligent system the ChatGPT-powered Smart Chatbot. Diving into the architecture of our chatbot, it's a web-based application serving as an automated response system built with the primary objective of enhancing the user experience of library patrons. The chatbot operates in two primary stages. Firstly, it employs a front-end user interface to receive textual inputs from users. Secondly, it gives back textual outputs that are generated by the underlying bot, both of which are delivered exclusively in English. The chatbot leverages the power of ChatGPT's application programming interface, processing these text-based exchanges and assigning them to specific virtual agents. Each of these agents is uniquely engineered to fulfill distinct tasks within predefined service domains. One such virtual agent worth mentioning is our EBSEO searching agent. Armed with the capacity to handle diverse searching tasks, this agent interprets and processes various input modalities, such as keywords, authors, titles, subjects, and ISBN numbers. These virtual agents are not only designed to fulfill tasks, but are also equipped with bespoke error handling mechanisms. For instance, when a patron seeks to reserve a study room and inputs their preferred date and time, should the requested time slot be unavailable, the system autonomously provides appropriate recommendations, aiding the user to reconsider their preferred scheduling, thus ensuring a seamless user experience. A significant feature of our chatbot's functionality lies in its capacity for multi-turn conversations. This is best exemplified in the study room reservation process, wherein the chatbot guides users to provide necessary details like date, time, patron's name, and their school email address, seeking missing information in an intuitive manner until the reservation is successfully completed. If the chatbot cannot provide an answer, the user will be navigated to start a live chat with a human librarian. Recognizing the critical role of human involvement, our system allows users to initiate direct conversations with a human librarian during working hours. For times when librarians are unavailable, an embedded form lets users submit queries to receive a response when the librarian is back on duty. From a structural standpoint, our chatbot is designed with an unwavering focus on cost efficiency, thanks to the implementation of caching mechanisms that optimize the usage of ChatGPT resources. Moreover, the modular design structure allows hassle-free integration of additional features, aligning with the evolving needs of the users as well as from the developers. I'll pass it to my team member, Steve, for a technological explanation and a more detailed introduction about this product.
Hello, I'm Steven. I'm gonna introduce you about the technology behind our intelligent chatbot. This chatbot gonna operate around the power of GPT-4 from OpenAI. So GPT-4 would be the main decision maker of our intelligence system, and to allow this LLM to interact with our API, our database, we're gonna use the React model. This React prompting model is released on 2022 in the paper. You can read about it here. And this is the diagram of how the React model working. So the strength of this model is it allow the LM to have better reasoning result, and also allow it to interact with the environment as well as observe the behavioral of the environment to give suitable decision. So now I'm gonna deep dive into how we use React model in this specific use case. Here is the diagram. The user gonna send a message. When the user send a message, this message gonna be injected into a prompt object. The prompt object gonna be included with the description of all the available tools. For example, one of the tools can be room reservation tool. It has this parameter to do to make a reservation. This name, room code, start time, and end time. And with this prompt, the LM can have a response structure like this. First is the thought. This part gonna help the LM have more time to think, which lead to a better reasoning result. And here's the action and action input. These two gonna allow the LM to interact with the environment around it. The action gonna be the tool name if the LM decide it need to use some tools, and the action input gonna be the parameters to use that tools. And if the LM is deciding to use some specific tools, those information gonna be parsed into here and fed into this tool. The tool have to do some operation inside. It's gonna respond with some message, maybe a success message, maybe some fail message saying that on the room with this capacity is already full, please choose another capacity, or do you want to split. That's it. And those information gonna be fed again to the prompt, and those whole prompt gonna be fed again to the LM to get and the LM gonna decide what to do next. So why do I have to decide as a loop like this? Yes, so it is for the use cases when maybe more tools gonna need to be used, or one specific tool gonna be have to be used more than once. For example, our library only have room with the maximum of 10 people, and the user want book a room of 20 people. So the LM gonna decide if the user wanna split into 2 rooms. If the user say so, yeah, I'm gonna do it in 2 passes. First, yeah, I'm gonna use the tools for first time, the room reservation tools for the first time. Here, if it's successful, the tool gonna return back some message to fed into the LM again. Now the LM have the information that I need to book 2 rooms, and 1 room is already booked. I need to book another room, so it's gonna give a response right here, and the tool is gonna be called one more time, and same operation happen. Tool response fed to prompt, and the prompt be fed back into the LM. Now the LM have the information that it need to make 2 room reservation, and 2 room reservation has been made. Now it can reach to the final answer, saying to notifying the user that to a room is already booked, and here is to confirmation ID. That's on the idea behind this model. So to be more specific how we use that model inside our architecture, let's go to our diagram right here. So here's the whole architecture of the chatbot. So first, this is the start menu. The user gonna decide if they wanna chat with the human, the real librarian on duty, or they want to chat with chatbot. If they wish to chat with the chatbot, the message gonna be fed into the chatbot right here. And first of all, their question gonna be checked with the caching system. If their question is a frequently asked Q&A, like who is the responsible librarian for mathematics, it's gonna be checked inside this caching system and get to the answer of that frequently asked question. If it's not, if the question from the user is not catch, it's gonna be fed into the rest of the chatbot. First, it's gonna go through the text classification model. This text classification model acts as an intention recognition model, and it helps the chatbot to decide which specific text agent should be used. For example, in our chatbot, we have 4 main agent. Building for room reservation agent. Second one is EBSCO search agent. This one is for searching for the article or research paper. Subject guide and librarian search agent. This is for searching the list of librarian responsible for some specific subject, or the librarian guides for each subject. And the final is general search. So for example, the message has the intention of booking a study room. It's gonna be go through only this agent right here, and this agent right here gonna be structured exactly like this React model, right? And first it's gonna be fed into the LM, and then if the LM decided that there's some missing information, gonna return to it gonna ask the user to provide more information, and if there is already all the information is there, it's gonna be is the LM gonna decide to use one of these tools. Maybe it's the room reservation tools, maybe it's the room checking availability tools, or canceling reservation, or it can be checking the building hours. And then the tool is gonna respond with something. And if there should be the end of only operation needed, it's gonna reach the LM gonna tell the user about the result. If it's not, the loop begin again to use another tools, or to use that same tools one more time. And if there is any error when any of the agent operating, it would be formed back to our human chat system right here, or going to our ticketing system if there is no librarians on duty at the moment. So that's all of the implementation details. To do those, here's our technology behind it. The first one is the Call Here API. This Call Here API is used in the text classification or the intention recognition model, because Call Here AI give a very easy solution to do this kind of task. So it would be a very good candidate here. Weaviate is a vector database. It's gonna be used in the caching system because the traditional no traditional database like maybe MySQL, PostgreSQL, or even MongoDB is very difficult to map similar sentences. For example, if we have sent to these two sentences, what is the opening hour of the buildings, and when does the building open? It's very hard to map these two sentences in the other traditional database, but it's very natural and easy and quick for Weaviate, a vector database, and it's very good technology here. And for the on the backend infrastructure, to ensure that the backend is scalable and type safety, we use Node.js and TypeScript. Okay, so that's all of the implementation details of the technology.
A conversational tool like this has several benefits, but it doesn't come without its challenges, which span across different areas. The first one is the potential for misuse of this tool, leading to unforeseen responses. This is primarily because it lacks the ability to distinguish right from wrong, potentially producing unwanted textual outcomes. In order to mitigate this, our developers have included additional protection to screen out such responses. Another issue is the inconsistent reliability of AI-generated responses. In the early stages of our development, AI responses deviated significantly from the intended track. However, things have significantly improved since the adoption of GPT 3.5 Turbo. Through fine-tuning, we have managed to make the responses more accurate and direct the virtual agent to perform the given tasks more precisely. The third challenge is the inadequacy of resources for development, ranging from technical support to financial assistance to server-side help. We are continuously striving to acquire more resources to ensure that the development process progresses smoothly. The final challenge lies in enhancing the efficiency and efficacy of academic library services, given the rise in online queries. The cost of implementing the GPT-4 model during development was substantial, and we anticipate a significant increase once the smart chatbot goes live. Increased use of the GPT-4 is likely driven primarily by curiosity and easy access to answers. To tackle this, our developers are devising a solution to store some question-answer pairs within a caching system before they are directed to appropriate virtual agents. This will not only reduce the cost of deploying the GPT-4 model, but also expedite the process of providing answers. The inclusion of smart chatbots in library services addresses a number of traditional library challenges. Firstly, it enhances accessibility. The 24/7 availability of chatbots ensures that users can obtain necessary help or information at any time. This is especially beneficial for users who may not be able to physically visit the library or those who prefer to access services remotely. Secondly, smart chatbots can handle multiple queries simultaneously, thereby increasing efficiency. Unlike human librarians, who can only attend to one user at a time, chatbots can manage numerous inquiries, ensuring that every user's needs are addressed promptly. Thirdly, the incorporation of AI in library services enhances the user's information retrieval experience. Smart chatbots can be programmed to offer interactive outcome making complex concepts easier to understand. This innovative approach to researching and learning brings a new level of meaning to library services, as they now extend beyond just providing information resources. Standing at the intersection of technology and library services, the ChatGPT powered smart chatbot is truly a testament to the future of academic libraries. As we move forward, we aim to further harness the power of AI and machine learning to refine and expand the capabilities of our chatbot, ensuring it continues to meet the ever changing needs of our library users. As we look into the future, there are numerous potential projects involving smart chatbots and library services. One such project could be the development of chatbots with higher emotional intelligence capabilities. Currently, most chatbots can only respond based on predefined phrases. Enhancing their emotional intelligence would involve programming the chatbots to detect and interpret the emotional state of the user based on their queries and respond appropriately. This could greatly improve user satisfaction and the overall user experience. Another potential improvement could encompass incorporating intelligent chatbot technology into other resources, such as enhancing information literacy, addressing complex research inquiries, and integrating with broader teaching and learning platforms like Canvas or Blackboard. The chatbot could lead users across these multi-domain tools, clarifying their functionality and helping users access the information they require. Additionally, future development could also entail the creation of multilingual smart chatbots. Such chatbots could serve to break language barriers in library services, providing assistance to users in multiple languages and thus enhancing inclusivity. The primary intention behind these developments is to create a more interactive, efficient, accessible, and inclusive library service. By increasing the capabilities of smart chatbots, library services can transcend traditional limitations and become more user centric. Furthermore, these innovations aim to redefine the meaning of library services. By incorporating interactive learning, emotional intelligence, and other capabilities, library services can become more than just a source of information. They can become platforms for holistic learning and growth, where users can not only access information, but also acquire new skills and gain a deeper understanding of various concepts. Overall, the entry of smart chatbots into the library service industry is truly a game changer. This innovative application of AI technology has the potential to redefine the library experience, bringing new meaning and depth to the services libraries offer. With further enhancements and development, smart chatbots are destined to revolutionize library services even further, setting the stage for a future where libraries serve as dynamic hubs of learning and innovation. Next, I'll pass it to my team member, Ayag Koral, for a comprehensive demonstration about our smart chatbot.
Hello, this is the library chatbot demo. So we have a pop-up here that's for the library chatbot. This will obviously be on the library website. So once we have a pop-up that has three different features right now, so we have either just the library smart chatbot, or talk to a human librarian, or get a ticket for offline help. So for example, for a ticket would be like we would enter your question, details, email, and then librarian, once they are online, they will get back to you through email. And then talking to a human librarian would, you can click on it and then it'll go through the chat with us API that handles the real librarians question answers, and other than that you can do a library chatbot demo. So we can go through the library smart chatbot. It'll ask you what it can help with. I can just say what can you help me with. So right now we have more features than it lists out here, because it's only picking like the top two priorities for now, and then it'll also book a study room reservation and then more information. So it says it'll help finding specific book
with a specialized tool, and then like finding librarians. It'll also book rooms. It'll also find journals, articles, find librarian hours and more. But for now, the main priority would be for an EBSCO would be for searching specific books, and more would be like room reservation. So let's start with a simple one like finding librarian. So find me a librarian for CS. So this would go into our API and then find out the subject and then the librarian that's associated with that subject. So this will understand that CS means computer science, and then find me a librarian that is has more expertise in computer science. So we have the person and then their contact information. So let's proceed into trying to book a study room. So let's book a study room. So this study room has a lot of parameters that it requires to book a study room. So like name, time, date, email, the confirmation, and what room do I want. So this will ask for everything. But if we, for example, if we like fail to provide any of this, it will give you, instead of giving an error, it'll like just try to reprompt you, so you get like a proper error handling, and then it'll keep on reprompting until it has all the parameters that it requires. So if I only say my name, it will understand that I only provided it my first and last name. I did not provide the email, date, or anything else. So it will understand that what is missing, and then ask me again. All right, so it's asking for more information. So I'm gonna just say, and this is asking for date in this format. But if this is like a smart enough chatbot, it's to understand what I want. So I'm gonna just say, book it for next Thursday from 1 to 2 p.m. So I provided my email and then the date and time. So even if we did not uh, format it correctly, it should figure out what start and time I want and what date I want. Oh, sorry, I spelled it wrong. So the email is, so I see, if we provide anything else other than the university email, it'll give us a similar error. But right now it's just a spelling mistake. But if I was trying to use my Gmail or something, because this is a university library and we're booking the room, we should be for the name. So I think it got confused on the date, but it should be just the 12th. Do you have any specific rooms? So since I don't have any preference or like capacity or like a specific code that I have, I'll just give a rough capacity. So I'll just say book the room for 7 people. So this should find me a room that can fit 7 people. So if I was providing like a larger number, like 20 or something, and it did not have enough room or like available room that had the capacity to try to split people into multiple groups that total up to at least 20. Alright, so I did get a confirmation email. So obviously this was a longer process than expected, but if I were to expedite the process, I could just type it in a single go, like book me a study room tomorrow from 1 to 2 p.m. Same name and email with for 3 people. And it should understand that I provided the same name, but if it does not find it in the context, it will try to reprompt it back based on the error message, but it should not. So once we note down this booking number, we can also use this booking number to cancel it. So here we see I got another room for room 101 with only capacity of 4 people. So since this had like 7 people, it needed a capacity of 8. So it is intelligent or like smart enough to understand like what rooms we need or like what based on the capacity, time, and everything else. So now we have a different booking number that we can use it for confirmation at the library or when we are like canceling it or for some reason. So once we demo this study room booking, I can also start showing you how we can find books, for example. So find me a book, book on machine learning in maybe Python. Yeah, so this is just a sample example title. So if it's in the matches like titles in the abstract or let's say fairly similar, it'll give us back the relevant information that we need. So this is not just limited to books, so we can also find articles, journals, and so on. We can find it based on authors, titles. We can also find it based on like the ISBN number and so on. So we just have to specify what we need, and then the chatbot is smart enough to find out what it is. So since these books are like online books, it'll say that you can access this through electronically. And if we were to click on this, it will lead us to the library website that has like more information on the book. So we have like everything that we need right here. And we have the electronic resource, we have the catalog record, we can find the abstract and so on. So find, I am reading good. I'm reading fragile things and finished it. Help find a similar book at the library. So this is a very vague request, considering it's just a chatbot, like a search field. But if I'm reading this book, all right, so it did find the exact book we're talking about, but then it also tried to find similar titles of the book. So if I say find me another book by Neil, so it did find more books by Neil Gaiman. So that's Sandman Book 1 and then Good Things. So this is also available in the library, so it gives you like which library it is available in. But this one book is only available online through maybe a PDF, so it did not list the location of where it is. So it can find us like help with research, help me with research, find me articles on machine learning and computer vision. So this just happens to be a research interest of mine. So if we search this, so it'll give out what the like a list of a few articles that would specifically be for like machine learning and computer vision. But if you wanted to be a little bit more specific, we could provide like the exact title or something similar to that. And this would go to the EBSCO query and then search it and then get us back relevant articles that we need with links to access it. So see, so we have like some like two computer vision and machine learning articles that we can now click on it and then access it through our like library website. So further testing would be so what if I wanted to know the library hours? So what are the library hours this Saturday? So seems like this error handling did work, like they did not understand exactly what I wanted, but it still give us like relevant error messages that we can then either recheck the website or continue again, like instead of having a problem and like crashing the chatbot. So this would be a slight technical fault, but then it's still doing what it's supposed to do. So if we rephrase it and then try to answer it, it will give us the correct answer. So when is the library open this Saturday? So normally our library is open from that. Okay, so